Welcome back. This time we have a problem from the shortlist of the International Math Olympiad 2010. This problem is proposed by Ukraine. We have A, B, C, D real numbers, and A plus B plus C plus D equals 6, and also the sum of the squares equals 12. We must prove this inequality that 4 times the sum of cubes minus the sum of powers of 4 is between 36 and 48 inclusive. So let us start to solve this problem. We will prove each side separately. That is, first we will prove the left hand side here, and then we will prove the right hand side. So this is the left hand side. We will prove this left hand side. Now we must have strategy to solve this problem. First, we just show the data here. These are the known values. A plus B plus C plus D equals 6. The sum of powers of 1 equals 6. And the sum of the squares equals 12. The known values. But we also need to find the inequality for this one right here. 4 times the sum of cubes minus the sum of powers of 4. How can we do that? How can we use something simple to have an inequality for this? We have here powers of 4, powers of 3, powers of 2, and powers of 1. We need those information. And we can just use, maybe the idea is that we might want to use this, a minus 1 powers of 4. Because this is exactly a powers of 4 minus 4 times a cubed. And if we take this minus here, minus of this, we have 4 times a cubed minus a powers of 4. This is just for one variable, that is variable a. And then we have here a squared and then also a. And we have a squared here and a here. Now this is just for one variable, that is a. If we do this for all the others, b, c, and d, and then we add them up, we will get the sum of squares and also the sum of powers of 1, right? And we also get this form right here, the second line, 4 times the sum of cubes minus the sum of powers of 4. So let us do that for the other variables, a, b, c, and d. Of course, the form will be the same, just with different variables. And if we add them up, we will get the sum of squares, and also the sum of powers of 1, and also this sum of powers of 4 and sum of the cubes. If we add them up, we have here sum of powers of 4 minus 4 times sum of cubes, and then plus 6 times sum of squares, and this will be a constant. And then minus 4 times sum of powers of 1. This is also a constant. So this is exactly equal to, since this is 12, sum of squares is 12. 12 times 6 is 72, and then minus 4 times 6 is 24, and then plus 4 we have 52 only. We have plus 52 here. Okay, and then, so we have now, let us look back here. We can just take the minus of the right hand side, and also for the left hand side, of course. So we get that 4 times the sum of cubes minus sum of powers of 4 is equal to 52 minus all of this. Right? So now the inequality that we want to prove is 52 minus the sum of this is greater than or equal to 36. Okay, so now, or in other words, we can simplify this inequality that the sum of the powers of 4 of a minus 1, b minus 1, c minus 1, d minus 1 is less than or equal to 16. Now we see here we have the sum of powers of 4, and we can see here it is much more simpler than the original inequality, because we only have the sum of powers of 4 now. And to solve this, notice that here we can take a look at this form right here, the sum of squares being squared, and this will definitely involve the sum of powers of 4, right? This will involve the sum of powers of 4, this is what we want, right? The sum of that what we want, and then plus something, and that something will be 2 times the multiplication, the product of the two combination for each of the two combination. A minus 1 squared times b minus 1 squared, and then a plus a minus 1 squared times c minus 1 squared, and so on, right? All the two combinations. And since we have here all in terms of squared, now powers of 2, right? So they cannot be negative. They cannot be negative. So all of this, 2 times all of this, cannot be negative. So at least 0. So we can see here that this sum of squares being squared is the sum of powers of 4 plus a non-negative number. So all of this, the sum of squares being squared, must be greater than or equal to the sum of powers of 4, right? We need that because using the sum of squares, we can use the identity a squared plus b squared plus c squared plus d squared equals 12, and also the a plus b plus c plus d equals 6. So we have here the sum of powers of 4 less than or equal to this, sum of squares being squared, and the right hand side here is exactly sum of squares minus 2 times powers of 1 and then plus 4, and we can compute all of this exactly because we can get here that is, this is just 12 minus 12 is 0, right? Sum of squares is 12, and minus 2 times sum of powers of 1 is 6 times 2, 12, so there will be 0, and we have here 16 only, and this is the inequality we want to prove. So we are done proving the left hand side of the original inequality. Okay, so now we'll prove the right hand side, that is 4 times the sum of cubes minus sum of powers of 4 less than or equal to 48. And this will be much more easier than the left hand side. So in other words, we also prove this. We just move the powers of 4 to the right hand side by just adding both sides by the sum of powers of 4, right? So here we have on the left hand side powers of 3 and the right hand side powers of 4. Now we have plus 48 here. Now can we make this something in terms of a squared, or I mean the powers of 2 and powers of 1? We might want to use A.M.G.M here. We can change the number 48 by 4 times 12, right? The sum of squares is 12. And you can see here the sum of the powers, 4 plus 2 is 6. 4 plus 2 is 6, right? So we can relate that to the powers of 3 because 6 divided by 2 is 3, and we might want to use A.M.G.M here. So we have here, we just rearranging here, we have the powers of 4 plus powers of 2 for each of the variable. And I think we might want to use the A.M.G.M here. Use the A.M.G.M here for each of these terms. We have that a power of 4 plus 4 times a squared is greater than or equal to 2 times the square root of 4 times a powers of 4 times a squared is just a powers of 6. And also the same for the other 3 terms. And this is exactly equal to 4 times the absolute value of a cubed plus 4 times the absolute value of b cubed plus 4 times the absolute value of c cubed plus 4 times the absolute value of d cubed, right? Because this is the square root of this is just 2 times the positive form of the a cube, right? And also for the others. And all of this is definitely bigger than or equal to without the absolute values. So again, we are done. We have proved that since all of this is bigger than or equal to all of this, 4 times the sum of cubes. And this means that we are done because this one here is exactly the sum of the powers of 4 plus 48, right? Okay, so this is the solution of this IMO 2010 shortlist problem number 2 from Ukraine. Thanks for watching and see you on my next videos.